All right, MDI today is name an angle whose intercepted arc is BC. And as we saw in the last video, there is more than one angle that can intercept the same arc. So if we find the arc BC, we know that this is a minor arc because there are only two letters. So if we find BC, that's this arc right here. So we see that lines from BC go here, here, and here, and we see lines from C go here, here, and here. So it looks like we have about 3 angles that are going to intercept this arc. So if we look at one of those angles, we can see that BOC is one of the angles that intercepts this arc. And because O is the center of the circle, and O is the vertex of this angle, that means that this is a central angle. We can also see that B and C also end up going to point A. So we can say that BAC also intercepts this angle, or this arc. And because A is a point on the circle, that means that this is an inscribed angle. And we also see that C and B intersect at D. So we can say that BDC is also an angle that intercepts this arc. And again, because D is on the circle, that means that this is an inscribed angle. All right, this is one of the things that we're going to talk about today, finding the measure of angle END. So if we find E, go to N, and then go back up to D, we can see that this is a central angle, and there's a special relationship between central angles and their intercepted arcs, which we're going to talk about in the lesson today. And then in the lunch, I also had the students draw a central angle and its intercepted arc, and an inscribed angle and its intercepted arc, just to give us some practice. Today, what we want to be able to do is we want to be able to use circle terms to solve problems. A lot of what we're going to be doing today is defining things and learning definitions and concepts. There's not a lot of application yet. We're going to get to that in the next couple of sections. But there are a few really important things that we need to talk about before we can move on. So again, this is from the previous lesson when we talked about central angles and inscribed angles. So we know that a central angle has its vertex at the center of the circle, which kind of makes sense because central makes sense. So we have here the center of the circle is also the vertex of this angle. And we also talked about intercepted arcs. So if we follow this vertex out to where it meets the circle, we can see that the intercepted arc is in between. It's kind of like the crust of the pizza slice or the crust of the pie piece. So the intercepted arc here would be arc AC. And again, we only need to use 2 letters because that's a minor arc. So here's the relationship between a central angle and the intercepted arc. They are the same. So if we know that the angle, the central angle, is 80 degrees, then that means that the arc is also 80 degrees. If we know that the angle down here is 57 degrees, we know that the arc up here is also 57 degrees. And this is vice versa. So if we know that the angle out here is, if we know that the arc out here is 73 degrees, then we can also say that the angle down here is 73 degrees. But we always know that the arc, the intercepted arc, and the central angle, I want to emphasize this, a central angle and its intercepted arc have the same measure. So whatever the angle is, the arc has the same measure. Because remember, a circle is measured in degrees too. So one of the things that we want to talk about is that there are 360 degrees in a circle, which means that there are 180 degrees in a semicircle. All right, 2 definitions that we're going to need to know are chord and diameter. So a chord is a segment that connects 2 points on a circle. So we can see that this line goes from point C to point D. They have to be 2 points on the outside edge of the circle, B and A. This is a chord. We could pick two other points. We'll call them E and F. Connect those two. This is a chord. Okay, and then there's a special kind of chord. Diameter is a word that you should be familiar with. A diameter is a chord that just goes through the center of the circle. So all of these are diameters because they go through the center of the circle. These are the longest possible chords that you can have in a circle. One thing that I do want to mention is that we'll call this S. This is not a chord. This is a radius. The radius goes from the center of the circle to the outside edge of the circle. A chord has to touch two spots on the circle. So if it only goes to the center, then it's not a chord. Okay, one of the important things that we want to talk about is that if two central angles are congruent, what that means is that their intercepted arcs are congruent. So remember that this little arc right here and this little arc right here mean that these two angles are congruent to each other, which means that they have the same measure. So if this angle were to say, let's say it was 36 degrees, then that means that the intercepted arc is 36 degrees. If this angle here is 36 degrees and we know that they're congruent, it means that this is also 36 degrees and we know that this is a central angle also. Its intercepted arc would also have to be 36 degrees, so therefore we have the two intercepted arcs that are also congruent. So if the two central angles are congruent, then we know that their intercepted arcs are also congruent. The other one that we want to talk about is chords can also have intercepted arcs. So if we see this red chord here, this red chord has this intercepted arc right here. And same thing over here, we see that this blue chord intercepts this arc right here. So if these chords are the same length, what that means is that their intercepted arcs have the same angle measure. And this one also works in reverse. If we know that these two arcs, these two intercepted arcs here are congruent, what that means is that these two chords would then be congruent. All right, and the last one that we're going to talk about before we do some examples is the arc addition postulate. So the arc addition postulate is very similar to the segment addition postulate that we learned earlier this year. All it says is that if we take arc AB, and remember this M in front here just means measure of. So this means that we're going to be talking about degrees. The measure of arc ABC, so remember this tells us what point to begin, this tells us what direction to go, and this tells us the point to stop at. So we're talking about start at A, go around the circle towards B, and don't stop until you get to C. So we're talking about this arc here. Well, this arc ABC is made up of two smaller arcs. It's made up of arc AB, which is this arc right here, and it's made up of the arc BC, which is this arc right here. So if we knew that arc AB was 38 degrees, and we know that arc BC is 157 degrees, all we would have to do to find the measure of this total arc ABC is to take these two arcs and add them together. So if the measure of arc AB is 38 degrees, and the measure of BC is 157 degrees, then when we add these two together, we could see that the measure of arc ABC is 195 degrees. If we had more arcs around the circle, we know that all of the arcs in the circle would have to add up to 360 degrees. We also know that if it's a semicircle, those arcs would have to add up to 180 degrees. All right, so in number one, we want to find the measure of angle KLJ. So, measure of arc KLJ. So that's what this means here. That's the symbol for arc. M just means measure, so find how many degrees are in arc KLJ. So remember, each one of these letters has a specific role. K tells us where this arc begins, L tells us which direction we're going to go, and J tells us where to stop. So K, go towards L, and don't stop until you get to J. So this is the whole big arc that we want to find. But we can also see that it's made up of 3 smaller arcs. It's made up of the arc KL, LM, and MJ. So if we want to find the measure of arc KLJ, all we have to do is add all 3 of these together to figure out what our arc is. And we know this one is telling us what the angle in the center is here, but we also know that because this is a central angle, we know that the arc has the same number of degrees. So this arc out here would also be 100 degrees. So if we take KL, which is 35, and we add it to LM, which is 100, and add that to MJ, which is 120, when we add all of those together, we can see that that gives us the total measure of arc KLJ, which is 155 degrees. So one of the things that we talked about yesterday is if we know that the whole entire circle is 360 degrees, we could just subtract out this little piece right here, because if the whole circle is 360 and we take out this piece right here, that leaves us with our KLJ. So if we take that and subtract out 105 degrees, we would also then get that 255 for our KLJ. So sometimes there are more than one way to do this. All right, on example 2, all we want to do is just name each one of these. And there are more than one for each, so it's up to you to be able to determine which one you want to use. A chord, remember, has to connect 2 points on the circle. So if we see that we have B and A, we could say that BA is a chord. We can also see that B connects to C, so BC, or CB, and we're putting lines above these because these are line segments, not arcs. We can also see that D connects to A, so DA would be a chord. And we can see that D connects with C, so DC or CD would also be a chord. We also could connect E with A, that would also be a chord. And that would also be classified as a diameter because it goes through the center of the circle. So we can see that that is a chord and a diameter. Okay, and the next one we want to name some central angles. And we know that in a central angle, the vertex has to be at the center. So any angle that we name has to have O in the center of its name. So we can see, again, this is one that we did in the introduction. We can see that EOB, angle EOB, is a central angle. We can see that COA is a central angle. I'm going to do that in a different color so we can distinguish between those two. COA, again, its vertex is at the center, so angle COA is a central angle. We can also see that DOB is a central angle. There are many, many more, but that gives you kind of a good idea of what you're looking at for a central angle. Now with those, we can see that each one of them has an intercepted arc. So if we were to look at angle EOB, we can see that the intercepted arc here is EB. EB is an arc intercepted by a central angle. We also have angle COA. Its intercepted arc is CA, and all of these are minor arcs, so we're only using 2 letters to identify them. And the last one is arc DB. Okay, I'm going to stop this video and do the last example on another short video.